This video lesson is about segments of intersecting lines. So, as we have previously discussed, meron namang mga lines na nag-intersect inside, outside, and on the circle. However, for today's topic, since we're after segments, ang concern lang natin yung mga nag-intersect inside and outside. Let me show you something first. So, among these illustrations, there are 6 circles, and they are grouped according to a certain category. Kayo yung mag-identify ng category or kung saan nag-intersect yung mga lines. Alright, so what about for OP? Okay, they are on the circle. What about S, R, and T? Circles S, R, and T. Outside, and lastly, inside the circle. Okay? So, ang concern lang natin ngayon ay itong 4 na situations na to or those lines intersecting outside and inside the circle. Bakit ito hindi? Okay. If they intersected on the circle, uh, kahit we're after the line segments. You're after the line segments. So, yung haba nitong line na to. From this point up to this point on the circle. However, kung tangent ito, kahit naman saan ko ilagay itong point na to or yung line na to, kahit saan ilagay itong line na to, it doesn't really matter. Kumbaga, maraming pwedeng maging length itong blue line, itong second line in reference to this tangent line or kung mag-intersect man siya dito sa tangent line na to. So, technically, wala talagang relationship. At since this is only a tangent, it only touches the circle at only one point. So, wala talagang length siya. It's only at one point. However, with these two intersecting second lines, kahit i-permanent itong isa, then itong isa naman ay i-move nearer or farther to the first, second line, wala rin naman masyadong epekto or walang masyadong relationship sa length nilang dalawa. Okay? Unlike itong 4 na to. And you will see later ano-ano yung relationships na yan. Alright, let's start off with lines intersecting inside the circle. So given circle O, okay, there are 2 lines identified as line 1 and line 2. Okay, as we can see, these are second lines. Okay, for the first second line or line 1, the one colored in light blue, okay, meron tayong tinatawag na segment 1 and segment 2. Let's identify which is the first segment. All right, that will be segment PR, and then segment RS, and then for line 2, so ito namang dark blue, what will be segment 3? Okay, that will be segment QR, and then segment RT. Now, let's identify the measurements of each. For PR, okay, you have 4. And then for RS, be careful with this one kasi hindi naman talaga siya 7. So, dito tayo magsisimula kasi sabi RS. So, dito, 1, 2, 3. So, that should be 3 only. Now, for QR, that will be 2. And then for RT, that will be 6. So, 8 kasi yung total minus yung 2 sa QR. That will be 6. Okay. Try to identify the relationship. Okay, kung hindi pa, let's have another example. So, for line 1, we have the segments AE and EC. For line 2, we have the segments BE and ED. Now, what about their measurements? For AE, it's 3. For EC, it's another 3. And then for BE, that should be 1. And then for ED, all right, 10 minus 1, that's 9. Oh, let's take a closer look. You have 4, 3, and then 2, 6. You have 3, 3, and then 1, 9. What do you think happens? Okay, multiplying the segments of the first line is equal to the product of the segments of the other line. So, segment 1 times segment 2 equals segment 3 times segment 4. Ano yun? Specifically, 4 times 3, that's 12. 2 times 6, that's 12. 3 times 3, that's 9. 1 times 9, that's another 9. So, equal lang yun. Pero kailangan, yung segment nung isang line, ang imomultiply, tapos yung segments nung kabilang line ang imomultiply. Hindi pwedeng pagpalitin yung any segment or any part nun. For easier reference or another easier way to recall this will be S1 times S2 equals S3 times S4. Ito yung mas madaling paraan. Wag lang kakalimutan na yung S means segment. Okay, next. So for this time, we have lines intersecting outside the circle. So outside the circle. And this time, we have tangent lines. Tangent lines. Now, for line 1, ito daw light green. So the segment is PQ. And for line 2, the segment is RQ or QR. Now, let's look at their measurements. Okay, 5. And then for RQ, that's another 5. Let's have another example. So this time we will have segments AB and BC or CB. What about their measurements? It's 6 and another 6. So what can we say? So for tangents intersecting outside the circle, segment 1 is always equal to segment 2. So yung mga haba daw ng mga segments will always be the same. So S1 equals S2. Next. For lines intersecting outside pa rin, kasi di ba 3 cases ito na outside, then 1 case for inside. Inuna natin yung inside kasi isa lang siya. This time we have seconds. This time we have seconds, 2 second lines. Okay? So for line 1, second ones. Asa ba yung second? Ito yun. Ito yun. So hanggang sa labas. So that will be segment AC. And then the external will be segment BC. For line 2, ito yun, yung dark blue. Asan yung second part dyan? That's EC. So, simula dito hanggang dun sa dulo. Asan yung external, yung nasa labas? Ito lang. And that will be segment DC. Now, let's look at their lengths. So, for AC, that's 10. For BC, that will be, again, hindi siya 10. Ito lang yun. That will be 4. For the second line, that will be 8, total of 8. Pero yung external niya, 5 only. Okay? Sana nakita na yung relationship. Kung hindi pa, let's have another example. So for the second line, that will be segment KM. Then segment LM for the external. For line 2, that will be segment PM and segment NM. Now, as for their measurements, KM is 12, while segment LM is only 3 units. For line 2, segment PM is 9, while segment NM, so yung external lang, external, 4 units. So, in summary, we have 10, 4, 8, 5. We have 12, 3, 9, 4. What can we say? Okay. For seconds outside, for second lines intersecting outside the circle, so second 1 times external 1 equals second 2 times external 2. What do we mean? 10 times 4, 40. 8 times 5, 40 also. 12 times 3, 36. 9 times 4, 36 also. Okay? So, for easy reference, we have S1 times E1, S2 times E2, S being used for second, and E being used for external. Last. What if this time we have lines intersecting outside the circle, but one is a second line and another is a tangent line? So for line 1, we have the second as segment AC, the external is segment BC, and for line 2, the tangent is segment DC. What about their measurements? That will be 9 and 1. For the tangent, that will be 3. Okay, let's have another. That will be segment KM and then segment LM. For the tangent, that will be segment PM As for the measurements, segment KM will be 12. Segment LM is 3, right? For the segment PM, that will be 6. So let's look at it closer. So you have 9, 1, 3, then 12, 3, 6. What could that be? This is for second tangent and outside. So you have a second line, a tangent line, and then the lines intersected outside the circle. All right. So second times external equals the square of the tangent. So 9 times 1, that's 9. 3 squared, that's also 9. 12 times 3, that's 36. 6 times 6, that's 36. So for easy reference, we have S times E equals T squared. Second external tangent. Okay, as a summary, it should look something like this.